Welcome back. So this video is going to be graphing logarithmic functions. Looking at your graphing log function notes that are posted on Google Classroom, just like exponentials, we're going to kind of break it down and then we'll do some examples. So your standard form for your log functions is going to be written like this. So it still has the h and the k. What you won't see is stretches and compressions with logs. We kind of just focus on the horizontal and vertical shifts. So you'll notice that b is still your base, h is going to still be your horizontal shift left and right, and k is going to be your vertical. However, we know that logs and exponentials are inverses of each other. So it only makes sense that because exponentials have HAs or horizontal asymptotes, that logs being their inverse would have a vertical asymptote. And this is going to be with your h. So looking at the example that was given, we have log base 4 of x plus 2 minus 1. So we will know that the base is 4. It's going to go left 2. And I also know that that means I'm going to have a VA at negative 2. And then I'm going to shift down 1. Notice that our parent function is just going to be the log base of x. So this one will be log base 4 of x. Log base 4 of x. The table is a little different than exponentials. So you will always use 1 and your base. So 1, 0 and your base, 1. Okay, so let's start graphing this example. I know it's already graphed for you, but let's pretend like it's not there. So if we go ahead and do 1, 0, and our base 1, so we know it's going to be a 4, 1. And I know that my VA is going to be at 0. So that will be your parent function. We know that our horizontal shift will be left 2 and our vertical will be down 1. We're just going to pick up those points and move them. And that is how you graph your log functions. So I'm going to be looking at example 5 that was uploaded on your Google Classroom because that's where the logs start. So if you're looking at log base 5 of x plus 6 plus 1, if we look at our parent function, so we will be plugging in 1. We know we will get 0. Then we will plug in our base, which is 5, and we know that we will get 1. So 1, 0, base, 1. Go ahead and plot those points. That for my transformations, I am going to be going left 6 and up 1. So I will move my points left 6, up 1. Okay, for domain and range, so for domain, now we have a restriction. So if you're looking at the blue graph, we know that our x's can be any number greater than negative 6. So we're going to write that in interval notation as parentheses negative 6, comma, infinity. And for our range, we know that it will go from negative infinity to positive infinity. Is graphing a log function. Example number 6, let's go ahead and identify our parent function. When I plug in my points, 1, I will get 0. And I plug in my base, which is 2, I will get 1. Go ahead and plot those points. For the transformations, I know that I'm going right 2 and up 5. So I will be moving both points right 2, up 5. The main is going to be that 2 to infinity. And range for logs will always be negative infinity to positive infinity. And just like graphing exponentials, that is as difficult as your logs will get. As long as you know what h and k do and you know the points to plug in for logs, you are good to go.